Welcome to the video for 3b, which is what we call compound and double angle formulas. So the compound angle formulas are just really the cumulative name for something called the addition angle formulas and the subtraction angle formulas. So just in short, what these mean is that if you want to find the sine, cos, or tan of two angles added together, instead of memorizing another exact value, you can actually just use one of these three formulas over here. Now, the actual use of the formulas can be a bit tricky. There are proofs of these as well, which kind of look like this. It looks pretty complicated. However, you don't need to worry too much about these over here, because you will actually get a formula sheet. So if you look at this formula sheet over here, on this formula sheet you have all the different compound angle formulas as well as the double angle formulas. These in fact will be given to you in your usual end of year exam formula sheet as well. So you can always refer back to these formulas whenever you need to use a compound or double angle formula. You don't need to actually memorize it, which is really good. Okay, so that is how that one works out. So let's just jump into some examples and see how we deal with these questions. Okay, so number one, part A says, evaluate each of the following in exact form. So the first one is sine 105 degrees. So all you need to do is realize, well, what is 105 degrees as a sum or difference of two of the basic foundation angles? And you could say that 105 is 60 degrees plus 45 degrees. Okay, so then what you can do is you can go back to the formulas of here and notice that sine of x plus y is sine x cos y plus cos x sine y. In other words, it's sine of the first times cos of the second, etc. So it's sine of the first, cos of the second, plus cos of the first, which is 60 degrees, and then sine of the second. So that's all you got to do. Sine of 60 degrees, well, that is root 3 on 2. You need to know your exact values. Cos 45 degrees, that's root 2 on 2. Cos 60 degrees is a half, and sine 45 degrees is root 2 on 2. So simplifying all this, we get root 3 times root 2 is root 6, 2 times 2 is 4, plus 1 times root 2 is root 2, and that's all over 4 as well. So what this ends up being is just one single fraction with the denominator of 4, and the numerator is root 6 plus root 2. And there we go. That right there is the answer for sine of 105 degrees. You can of course verify this on CAS as well. Next one is cos of pi on 12. Now this one might be a bit tricky to sort of see what the addition or subtraction is. So I'll tell you right now that pi on 12 is just pi on 3 minus pi on 4. Okay, and you can of course verify that if you so prefer. So this one is pi on 3 minus pi on 4. Minus pi on 4, there we go. So what's the cos difference angle formula? Let's go back to our formulas up here. So cos of x minus y is cos x cos y plus sine x sine y. So it's just the product of the causes of the two angles plus the product of the sine of the two angles. So this will be cos pi on 3 cos pi on 4 plus sine pi on 3 sine pi on 4. So cos of pi on 3, that is a half. Cos of pi on 4, that's root 2 on 2, plus sine of pi on 3 is root 3 on 2 times sine pi on 4 is root 2 on 2. So this one is going to be root 2 on 4 plus root 6 on 4. which again simplifies to root 2 plus root 6 all over 4, which pretty much is exactly the same answer as what sine of 105 degrees is. Is it a coincidence? Ooh, I think not. Okay, let's go to tan of 5 pi on 12. Okay, this one's quite interesting. So, how do you get to 5 pi on 12? Well, one way of looking at that is like this. You could think of 5 pi on 12 as 3 pi on 12 plus 2 pi on 12. Okay, because 3 pi plus 2 pi is of course 5 pi. So that really is tan of pi on 4 plus pi on 6. So that's one way of looking at what 5 pi on 12 is. So again, going back, what is the tan addition angle formula? So tan addition is tan x plus tan y over 1 minus tan x tan y. So we add the tans and then divide by 1 minus the product. So that's going to be tan of pi on 4 plus tan of pi on 6 divided by 1 minus tan pi on 4 tan pi over 6. Okay, so tan pi on 4 is 1, tan pi on 6 is root 3 over 3, and then 1 minus tan of pi on 4 is 1 times tan of pi on 6 is root 3 on 3, so that's just root 3 over 3. Okay, so you can actually simplify that a bit more. We can write that as 3 plus root 3 all over 3 divided by 3 minus root 3 all over 3. So that's equal to 3 plus root 3 over 3 minus root 3. Now, if you prefer, you can, of course, rationalize the denominator for this one. If you do so, you should end up with 9 plus 2 root 3 plus 3 all over 9 minus 3, which is 6. So that's 12 plus... that shouldn't be 2 root 3. That should be a 6 root 3. My bad. Let's fix that up. So 6 root 3, 12 plus 6 root 3 all over 6. And you just end up with 2 plus root 3. And of course, you can check that on the calculator and you'll get the same thing as well. Okay, so that is how you work out what tan of 5 pi on 12 is. A slightly larger set of instructions to get through there, but it's just you're just really doing some algebra over there as normal. All right, so that's your answer, 2 plus root 3. Well, the initial answer would have been 3 plus root 3 over 3 minus root 3. Excellent. So let's go to this particular one over here. We have theta and phi are acute angles. In other words, both of these angles are between 0 and pi on 2. What we also know is that sine of theta is 1/3. So theta is some acute angle where sine theta is 1/3. And phi is some angle where cos of that angle is 4/5. Our job is to find cos of theta minus phi. So the best way to start a question like this is to go back to the subtraction angle formulas and look at sine of x minus y. So sine x minus y is sine x cos y minus cos x sine y. It's just really the minus version of the addition angle formula. Okay, so let's write that out first. Sine of theta minus phi is going to equal sine theta cos phi minus cos theta sine phi. Okay, so what do we have and what do we need? Well, we currently have sine theta, so this one's check, and we have cos of phi. So the first part of the equation we certainly have, sine theta cos phi, but cos theta and sine phi we don't have just yet. So let's go ahead and actually figure that out. So if sine theta equals 1/3, that means that you can draw a triangle like this, right angle triangle. Here's theta, here's a right angle, and if sine is 1/3, the opposite is 1, the hypotenuse is 3. So then applying Pythagoras to this, you should get root 9 minus 1, which is root 8, which is really 2 root 2, and that is the adjacent. In a similar fashion, we can get the value of sine of phi. So if cos of phi is 4 and 5, again, let's draw something similar. So this time we have phi inside. Cos is adjacent over hypotenuse, that's 4 and 5. So the opposite will be square root of 25 minus 16, which is root 9, which is really 3. Excellent. So what we can say now is sine theta, well, that's just 1/3, times cos of phi, that's 4/5, minus cos theta. So now you're now looking at this triangle right here. Cos of theta is adjacent over hypotenuse, so that's 2 root 2 over 3, multiplied by a sine of phi. Let's look at this triangle down here. Sine is opposite over hypotenuse, which is 3 on 5. Let's go ahead and simplify this. 1 times 4 is 4, 3 5s are 15. And then 2 root 2 times 3, that's 6 root 2 over 15. So our final answer is 4 minus 6 root 2 all over 15. Unfortunately, there's no single common factor, so that is it. And the beautiful thing about this one is we were able to get the value of sine theta minus phi without even knowing what theta or phi were. So we don't know what theta is, we don't know what phi is, but we know that we can get sine of theta minus phi. In a similar fashion, you can get sine of theta plus phi, cos of theta minus phi, and so on and so forth. Okay, so that's there. Now, of course, after doing questions like that, you might be wondering is it a trick question or is it a trig question? Certainly something to think about as you move through the examples. Okay, so now let's look at some double angle formulas. So these ones are a bit different in the sense that instead of looking at addition or subtraction, we're just looking at at an angle being doubled. And there's one for sine, cos, and tan respectively. Okay, so here are the double angle formulas. As you can see, they are on the formula sheet as well at the very bottom of it. So of course you can refer to the formula sheet when you need to access double angle formulas as well. Okay, so let's jump straight into an example and see how this works out. So let's first one, we have to verify that sine of pi on 3 is equal to root 3 on 2 by using an appropriate double angle formula. Okay, so sine of pi on 3, well, the first thing you need to know is that pi on 3 is pi on 6 times 2. So pi on 3 is just double of pi on 6. So what that means is we can find sine of pi on 3 by using the double angle formula for sine. So that's 2 times pi on 6. And the double angle formula for sine is 2 sine times cos. So that's 2 sine pi on 6 cos of pi on 6 as well. So that's 2 times sine of pi on 6 is a half. Cos of pi on 6 is root 3 on 2. 2 and a half cancel out to get 1. So you end up with root 3 on 2. Done. We have verified it. Hashtag QED. That is it. That's the verification that sine of pi on 3 is certainly root 3 on 2 via using a double angle formula. Okay, so now let's look at this one here. We are told that sine theta equals root 5 on 3, and theta is in the second quadrant. So this is quadrant 2. Okay, so we're told that sine theta equals root 5 on 3. We have to find the exact values of sine, cos, and cot of 2 theta, each respectively. Right, so first things first, it's probably a good idea to work out what cos of theta is, because remember, the sine of 2 theta formula has cos in it. So let's go ahead and draw a triangle. So here is going to be a triangle right there. There's the right angle. Theta is there. Sine is opposite over hypotenuse. So we have root 5 over 3. That gives us sine. So the adjacent is going to be the square root of 9 minus 5, square root of 4, and that is simply 2. Okay, so we've got that over there. Now that's our triangle, but remember that theta is really in the second quadrant, so cos will actually be negative. So let's write that out. Sine 2 theta, that is equal to 2 sine theta cos theta. That's 2 times sine theta is root 5 on 3 times cos theta, which is negative adjacent of a hypotenuse, which is 2 over 3. So multiplying all that out together, we get 2 times root 5 times negative 2. That's negative 4 root 5 all over 9. And there we go. That is sine 2 theta. Again, we have no idea what theta is, nor does it matter. All that we need to worry about is that we know what sine and cos of theta are, and therefore we can use that to find the values of sine 2 theta and so on and so forth. Right, now let's look at cos of 2 theta. Now cos of 2 theta is a bit unique in the sense that it's actually got multiple versions. So if you look here, cos 2x, you have cos squared minus sine squared, or 1 minus 2 sine squared, or 2 cos squared minus 1. In general, it's probably easiest to use one of these two, and the reason behind that is because those two formulas rely only on a single sine or a single cos, whereas this one up here relies on you knowing both sine and cos, and if one of your sine or cos is wrong, then you'll get that entire one wrong. So it's better to just focus on one of the two of them. And also another bit of advice, you want to use something from the question rather than an answer as far as you can help it, because if something went wrong with any of your other working, at least you're using the correct number from the question. So I'm going to use cos 2 theta as 1 minus 2 sine squared of theta. So I'm going to use that version so I'm going to use the second version of the cos 2x double angle formula. So I have 1 minus 2 sine squared theta. That's 1 minus 2. Now if sine is root 5 on 3, then sine squared is just root 5 on 3 all squared. Okay? So that's 1 minus 2 times root 5 on 3 squared is 5 on 9. So that's 1 minus 10 on 9. In other words, that's just negative 1/9. There we go. So that's the value of cos 2 theta. Whatever theta is, you double it and take the cosine of it, and you will get negative 1/9. Excellent. Now let's move on to cot 2 theta. This one is going to be quite easy, fortunately. Cot is really just 1 over tan of 2 theta. Now, we know that tan of theta is sine over cos, so tan of 2 theta would be sine 2 theta over cos 2 theta, and the reciprocal of that, well, is just going to flip the fraction. So we end up with cos 2 theta over sine of 2 theta. And luckily we have both of those numbers. Cos of 2 theta is neg 1/9. Sine of 2 theta is going to be negative 4 root 5 on 9. So the denominators will cancel out, and so will the negatives. So we end up with 1 over 4 root 5. And now rationalizing that, you should get root 5 on the top, and 4 times 5 is 20 on the bottom. And there we go. Cot 2 theta equals root 5 on 20. Now, one way to, I guess, verify all these answers is you can go to the calculator and do a menu 3-1, solve sine theta equals root 5 on 3, and give the domain of pi on 2 to pi. Out will come an angle which won't really make too much sense. It'll be a bit of a strange one because it's not an exact value, of course, from our table. So you can do that, and then you simply type in sine of 2 theta, and then you sub in the previous result of theta, and then you'll be able to verify sine 2 theta, cos 2 theta, and cot of 2 theta. Right, now let's look at the very last one. So let's simplify the expression cos 4 2 theta minus sine 4 of 2 theta. And we have to express our answer in terms of cos 4 theta. So this is very similar to what we ended 3a with, but this time we've got powers of 4 there. Right, so what I'm going to do is I'm going to start by copying the question. Cos 4 2 theta minus sine 4 2 theta. And what we can do is we can write that as cos squared 2 theta squared minus sine squared 2 theta squared. So this one, remember you can use the difference of two squares formula. So this will be cos squared 2 theta minus sine squared 2 theta, and then cos squared 2 theta plus sine squared 2 theta. Now, this is something pretty amazing. If you look at the second bracket here, cos squared plus sine squared, well, that's just the Pythagorean identity. That's just equal to 1. Beautiful. Well, that's gone. So we really just got cos squared of 2 theta minus sine squared of 2 theta. And if you just look at that just a bit in detail, you might recognize something a bit familiar. We've got a cos squared minus sine squared. Didn't we just see that before? Well, if you look up here, hey, there is cos squared minus sine squared. So cos squared angle minus sine squared angle is just cos of 2 times that angle. In other words, cos squared of 2 theta minus sine squared of 2 theta is really cos of 2 times 2 theta, which is simply cos of 4 theta. And the question wanted our answer in terms of cos 4 theta. And what do you know? We've got our answer which is exactly cos 4 theta. So the answer is in terms of cos 4 theta. Excellent. So there we go. That is how you simplify that sort of expression using a double angle formula. All right, so to finish off this lesson, sometimes when you're doing a bit of trig, you might use your calculator to help you, but then when you realize that your CAS was in degree mode the entire time, you're unfortunately going to have a bad time. So make sure when you're doing trig that you remain in radians mode. If you do need to work in degrees, you can use the degree symbol from the pi menu, and you can use DMS, etc., etc. Excellent. Well, I hope that that lesson there made sense. There's quite a bit going on over there. But again, just make sure you have your formula sheet next to you when you're doing the questions, and everything will be fine. As always, any questions, please don't hesitate to ask. Good luck with all the questions and going through all the concepts. See you next time. Bye-bye.